Hello, y'all. Darrelly Berry Jr. back for some more physics. And I won't be here for long this time. I'll do a little bit of reading. And everything looks good as far as the stream, as far as I can tell. All right, yep, I think we're good. And if you pop in, be sure to drop a line. Let me know if you have any questions or comments. I'll probably be back later today as well. But we'll see. So I've actually started on a new section here. And hold up. There we go. Infinitesimal rotation. So these sections are pretty short. So I may get through the whole section, maybe not, but I plan on staying for no more than 30 minutes at the moment. Let's see how far we get. In the previous sections, various matrices have been associated with the description of the rigid body orientation. Okay. However, the number of matrix elements has always been larger than the number of independent variables. Okay, because we had 9 matrix elements and only up to 6 variables, I recall. And various subsidiary conditions have had to be tagged on. Now that we have established that any given orientation can be obtained by a single rotation about some axes, by how we set our coordinate system, it is tempting to try to associate a vector characterized by 3 independent quantities with the finite displacement of a rigid body about a fixed point. Certainly a direction suggests itself obviously, that of the axis of rotation, and any function of the rotation angle would seem suitable as the magnitude. But it soon becomes evident that such a correspondence cannot be made successfully. Suppose A and B are 2 such quote, vectors associated with transformations A and B. And to quantify as vectors, they must be commutative in addition, right? With the addition of 2 rotations, i.e., let me make sure I didn't miss a chat. I think my window's blocking it. Welcome, Ahmad. How you doing? Hopefully you're doing well. Thanks for popping in. Thanks for dropping a line. Won't be here long. Just do a little bit of reading. And sure, I'll be back tonight, though. Let me know if you have any questions. With the addition of 2 rotations, i.e. one rotation performed after another, that has been seen corresponds to the product AB of 2 rotations, 2 matrices. Right now it's 12:49 p.m. my time, so I'm in Central Time. What time is it by you? Here it's the middle of the day. Aha, yeah. But normally I am in 7:50 a.m. Normally I do start around that time. That's what time my show is on Saturday, local time. So yeah, so it looks like we're about 8 hours apart. So that means normally when I'm on like 4 a.m. for you. So yeah, thanks for logging on. And I guess you're a night bird like me. I'm usually up late as well. I can't be up late as much anymore because I have to wake up for class and such. But normally I would be up like almost all night. So we know that the rotation thing, and we looked at that earlier. What was it? It was the ABC thing. Yeah, right here. So we see that we had 3 rotations after another when we were deriving the Eulerian angles. So 3 separate rotations in a row ends up being a multiple of the 3. But they're saying if we were to try to consider rotations vectors, it wouldn't work because you add vectors, you don't multiply vectors when you, like if you have a vector A and a vector B and you can combine them into C, it's A plus B equals C. But you have a matrices, and it's times equals C for rotations. So 1 rotation, 2 rotations equals what? It's probably even hard to even draw it separately like that. A the rotations. What book is this? This is Classical Mechanics by Goldstein. It's a graduate introductory. It's a the lower level of graduate level mechanics. Classical Mechanics by Goldstein. So this is pretty sure I have the book title up in here. I'll flash the book title real fast. Maybe I don't remember which screen I had it in. Let's see. Oh, here we go. I just didn't copy it into that. I guess I don't have the book cover readily available right now. I can add it really fast. One moment here. So that's the book right there from my lead screen, Classical Mechanics by Golds. So it's a pretty cool book. I think for the most part it's written well, but I think some things are not so clear. But our professor's really good about explaining things, so it works out in the end. However, matrix multiplication is not commutative. Okay. So A, B equals not B, A. Hence, A and B are not commutative in addition and cannot be accepted as vectors. This conclusion that the sum of finite rotations depends upon the order of rotations is strikingly demonstrated by a simple experiment. Thus, figure 4.9 illustrates a sequence of events in rotating a block first through 90 degrees about the z prime axis fixed in a block, and then about 90 degrees about the y-axis, while figure 410 represents the same rotations in reverse order. Oh, let me go back to the dual. The final position is markedly different in the two sequences. So, the book, we rotate, what did it say, around the z-axis first, z then y. So, rotate about the z-axis, which is vertical. Or is my mouse think it is? There it is. So, we first rotate twisting around the z-axis, so it's spinning like this. So now it's turned sideways. Then we spin in y, which is now turning it down, so it's flat that way. On this one, we twist first in y, which means we twist it down first. Then we twist in z, so now it's vertical. So we can see that rotations in different orders does not produce the same result. Give me a moment, I'll copy this in. This page, what? 64. And the mom says, I don't understand why you stream, not to offend you, just curious. Probably mainly because I enjoy it. And it helps me stay focused in my studies. So it's pretty much the main reasons. People find it helpful as well. Some people chime in or contact me and let me know it helps them out if they're studying, happen to be studying the same thing I'm working on. So that's about it. That's about it. We have this. Awesome. Thanks for dropping a line. So this is what we have. Rotate vertical position, rotate Z, rotate Y, vertical position, rotate Y, rotate Z. While a finite rotation thus cannot be represented by a single vector, the same objections do not hold if only infinitesimal rotations are considered. An infinitesimal rotation is an orthogonal rotation transformation of coordinate axes in which the components of a vector are almost the same in both sets of axes. The change is an infinitesimal. Oh yeah. This is Kindle. It's not. I often read on Kindle though. A lot of my books are on Kindle. So it works out pretty well. Sometimes depending on the file, the search option doesn't work so well. But I think in this book so far, the search and everything has been fine. A search rotation. Uh, so searching. Oh, it's working. All right. So it's saying that if we have a small rotation, such that the vector is not. Oh, there we go. Maybe you got a search term show up. So search works all right. So it's pretty cool. I have the paper copy as well, which I have to look at sometimes because the symbols in this document sometimes are not so clear. For the scan books like those not originally written in text, it's trash in Kindle. Could be. I know one of the books I have is like literally a image scan. I mean, the bad thing about it, you can't search it, but it does look very book-like. So I got a little bit used to writing in text. I think it's pretty cool. At least LaTeX with the text editor, I believe. Thus, the x1 prime component of some vector r on the passive interpretation of the transformation will be practically the same as x1, the difference being extremely small. So now we get into the small things again. So hold up. So it's saying that I'm going to draw this out. So this is x, y, z. I'm going to rotate this just a little bit so that this is x prime. This is y prime. And z stays the same. We'll say that phi is very small. So what they're saying is that, yes, text maker, that's right. I used to practice with it a bit. I haven't practiced with it in a while, but I do plan on getting into it again. I mean, the books, I mean, they look all right, but I know I have to write papers in LaTeX. So I wrote a paper this year. Um, and well, I guess technically I wrote it last year, between last year and this year, or earlier this year. I wrote a paper. I used to practice with writing in text maker and LaTeX, which was cool. It's published in the McNair Journal, which I need to get a copy of myself, actually. But it's published in the McNair Journal, so it's not like a big scientific journal, but it's basically a school organization that promotes science. And I did research in that organization, and they have their own journal. But I believe it's publicly available somewhere. I need to get a copy myself so I can have it as a souvenir. Thanks. But I sure I'll get a copy one day so I could go over the paper in stream. So thanks for reminding me of that. We have x1 equals, or x1 prime equals x1 plus a little bitty change. Now, keep in mind that, oh, I forgot. See, they're calling it x1 and 2 instead of y. So I gotta get in that habit. But I used to hate back in the day when I first uh, in my earlier undergraduate, uh, but it's not so bad in the end. Just get used to it. So we have Z3 prime. Oh yes, I can do that. I can put that on Discord. Of course, do have the PDF of it. I actually planned on updating it to publish to a journal. But I noticed my partner on the paper, a professor I work with in my research, he was really busy, so I didn't want to, bother him with dealing with his classes and all. So I just let it be what it was. So it's still cool. Undergraduate research had an undergraduate paper, but I don't think it's ready for like a journal, which is why I didn't really publish it too much widely. So I may still update it. So I think I need to uh, oh, like one thing I want to do is look at. I was basically looking at the Persepi cluster. I'm pretty sure if I looked at another cluster, they're just things I could do to update it. So we'll see. I may go ahead and update it and probably send this to a journal and do a show on that one. So we'll see how it goes. I mean, it's not bad, but it's undergraduate research. It's solid undergraduate research, but I wouldn't like expect Nature to publish it or something like that. And keep in mind that this is phi 1 1. This is what is this? 2 2. Phi 2 2. And phi 3 3 is 0. So E1 1, that's the change between those X1. Plus a little bitty change 1 2. So they went to 1 2. I thought they would go to 1 1. So they're doing everything off 1. So what they're saying is they're going 1 1 right there. They're going 1 2. And then they're going 1 3. X2 plus a little bitty change 1 3. X3. So this is what it seems like they're doing. They're taking these three angles. All the angles are coming from the uh, original x-axis, which is what it seems like they're doing. I mean, you can get the full rotation from that. So, I mean, it makes sense from that perspective. Of course, well, hold up. Yeah. Because before, psi 1 1 and psi 2 2 would be the same. But here, you have psi 1 2 equals pi plus psi 1 1. Because you have the 90 degrees between x1 and x2, and then the shifted psi amount to get to x2 prime. So maybe that's why they did that. So that seems that would mean that E1 2 equals, I guess I can't necessarily do that because then it make clear what units or what terms they have an E1 1 in. They just guess a matrix element. So won't be able to put it in those terms. The matrix elements epsilon 1 1, 1 2, etc. are to be considered as infinitesimals, so that in subsequent calculations only the first non-vanishing order in Eij need to be retained. For any general component xi prime, the equations of infinitesimal transformations can be written as So we have xi prime equals x I plus epsilon I j x j, which equals, is interesting. So it seems like they're saying that this equals delta ij xj plus eij xj, which equals delta ij plus eij xj. Let me check the paper copy, make sure I'm seeing these symbols right. So this means that this is I, this is I, this is I, J, this is J, I, J, J, I, J, J. And so it does work out with what we had before. The quantity delta ij we recognize as an element of the unit matrix. And equation 4.65 appears in matrix notation, right? We have x prime equals should be the identity matrix plus e x. And this is matrix notation. It's interesting. Equation 4.66 states that the typical form of the matrix of an infinitesimal transformation is 1 plus e. i.e., it is almost the identity transformation, differing at most by an infinitesimal operator. That's right, because it says the same vector, but just a slight change. Everything is the same except a very slight change. All right, this seems like a good place to stop on page 165. And I may be back later to continue from here. And Thank those who popped in. Thanks for dropping a line, Ahmad. And I'll see you likely later today. If not later, I'm sure I'll be back tomorrow. We have fall break Monday and Tuesday, so I'll probably be on streaming at various times, even though I do have a writing workshop thing. So we'll see what times, probably in the evening time. So thank you all for showing up. Like, subscribe if you haven't. I'll see you all next time.